Good morning, honors pre-calc students. Mr. Duranko here. We're still in section 10.1 and we're still learning for another week. I think I'll have two more lessons like this for you, one more after this. Um, and this one, as most, is pretty easy if you pay attention. We're finally getting to the last part of this section, and we're going to talk about series now. We've talked about a sequence, like here's, for instance, a sequence 1, 3, 5, 7. A series would be just the sum of those numbers, and so it would be 1 plus 3 plus 5 plus 7. And since there's only 4 terms here, this would be a finite sequence. However, we could have an infinite sequence, right? We could go 1, 3, 5, 7, and then if you see dot, 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 that means that we'll go on forever. And the infinite series would then just be summing all of those numbers up as it goes, and obviously that would end up being a big number. We could find a partial sum at any point, though, along this infinite series. And so, for instance, the second partial sum would be the sum of the first two terms. The third partial sum would be the sum of the first three terms. So I have an example here that wants us to find the fifth partial sum of this expression. And so what we would do is we would find all of the terms up to the fifth. So the first term would be 1 squared negative 2. The second term would be 4 minus 3, which is 1. Third term would be 9 minus 3, which is 6. Fourth term would be 16 minus 3, which is 13. And the fifth term would be 25 minus 3, which is 22. And if we add all those up, you can see we have 35, 41. 42 minus 2 is 40. And so the fifth partial sum of this would be 40. That's all for today. Nice, easy, but very important topic as we move towards calculus. We'll see this stuff again. So anyway, if you have any questions, don't hesitate to email me, and hope you guys are doing okay. This is Mr. Duranko signing off. Bye.